So as you begin to study for exam 2, in addition to the exam from last year that you should use to practice, I wanted to provide you with an opportunity to practice these creative exercises where you're asked to write as many correct, distinct, and relevant facts as you can about a particular statement. And in this statement, you're told that you're reacting 1.45 liters of a 0.41 molar concentration solution of hydrobromic acid with excess calcium. And then you're provided with a chemical reaction, or the chemical equation for this reaction, where 1 mole of calcium, which is a solid, reacts with 2 moles of hydrobromic acid, which is an aqueous solution, to produce 1 mole of hydrogen gas and 1 mole of calcium bromide, which also is an aqueous solution. So in this, one of the first things that I'm going to do, because I see that I have a volume and a concentration, is I'm going to convert molarity to moles. And we do this using the volume and then molarity as a conversion factor, because we know that molarity is equal to moles per liter. So I'm going to start with 1.45 liters of HBr. And then again, I'm going to use the concentration of this solution, which you're told is 0.41 moles of HBr for every 1 liter of HBr. And there I should be able to see that liters of HBr will cancel out, and I'm going to be left with a value that's moles of hydrobromic acid, or HBr. So from here, once I plug this into my calculator, I get a value of 0.595 moles of hydrobromic acid. So that could be one of your correct, distinct, and relevant facts. And then from there, the next thing that I can do is probably do some stoichiometry to figure out, okay, well, how many moles of calcium bromide could I make from this many moles of hydrobromic acid? So what I would do is I would take 0.595 moles of HBr, and I would look to see that I make 1 mole of calcium bromide for every 2 moles of HBr. So again, I'm going to use that as a conversion factor. That's the stoichiometric factor. So 1 mole, I need 2 moles of HBr for this. Again, this came from the stoichiometric coefficient. And then if I plug this into my calculator, I see that the theoretical yield for my moles of calcium bromide is around 0.297 moles. So that, again, is another distinct and relevant fact about this statement. But what else could we do? So another thing that we've talked about in this class is converting units. So if you wanted to take 1.45 liters using the conversion factor for milliliters, this would be one type of distinct and relevant fact. So this would be 1,450 milliliters. Okay, what's another thing that we can do? So I know that aqueous solutions are ionic compounds that can be separated into their constituent ions. So I can take this calcium bromide solution, which is aqueous, and I know that that separates out into the constituent ions. So this makes calcium 2 plus and 2 bromide ions. Now, you couldn't do this also for HBr and get credit, because it wouldn't be a distinct and relevant fact. It would be basically the exact same concept. But if you do this for one of the molecules, this is a totally reasonable statement. Another thing that you could do potentially is write the complete ionic equation. So we have calcium, which is a solid, so that doesn't separate out into its component ions. We have 2 H plus ions, which are aqueous. We have our 2 bromide ions, which are aqueous, and that makes H2, which is a gas, so it doesn't separate into constituent ions. And we have calcium 2 plus ion and 2 bromide ions. That is our complete ionic equation. So from here, some other things that you could say about these molecules is if you wanted to do a naming. So if you named these compounds, that would count as one statement. And I'm just going to pick the calcium bromide, for example. So CaBr is Br2 is equal to calcium bromide. Now, if you did this for hydrogen gas, calcium, you couldn't add on to the number of statements that you provided because they're not distinct and relevant. So if you do a naming answer, then you can only do one name to get credit as a distinct and relevant fact. Another thing that you could say about this problem, because you're told that HBr is reacting with excess calcium, is that HBr is the limiting reactant. So that is the limiting reactant. And at this point, you have satisfied the 7 rules. You have satisfied the 7 rules indicating that you would get full credit for this because you're told you receive 2 points for each one and you need 7 statements to get full credit. But we could also do some other things with this. So for example, you could say, look up in the periodic table that hydrogen is about 1 gram per mole, and bromine, if you looked in the periodic table, has an atomic mass of about 79.9 grams per mole. So therefore, the overall molar mass of HBr is 80.9 grams per mole. And then remember, if you're solving, for example, the grams of something, and you're using the molar mass, those things only count as one distinct fact. So the fact that I have 80.9 grams per mole for HBr needs to be used in order to get full credit for this. We can take what we solved for at the beginning, which was 0.595 moles of HBr, and figure out how many grams that is, because we use the molar mass of a compound to convert between moles and mass. So we're trying to convert between moles of HBr to mass of HBr in terms of grams. So we're going to use this 80.9 grams of HBr for every 1 mole of HBr. And then you should see that moles of HBr would cancel out. And if you perform this calculation, you would find that 0.595 moles of HBr corresponds to 48.1 grams of HBr. So these are just some additional examples that you can use in order to satisfy all these distinct and relevant facts. There are a variety of others as well that you could use. So for example, just off the top of my head, you could say in this problem that calcium, because it's just in its solid state, is being oxidized. And remember, being oxidized means that it is losing electrons, because calcium in its solid state has an oxidation state of 0, and calcium in calcium bromide is calcium 2+, so it has a 2+ oxidation state. So this would be a way of saying that calcium is being oxidized because it's losing electrons to become that ionic compound. Now, if you provided the oxidation states and said that other things are being oxidized or reduced that were correct, it would still only count as 1 credit for an answer because it is the same concept. And that's what I'm looking for really, is different concepts being used to satisfy your distinct and relevant fact. All right, so good luck studying, and remember that these problems are not meant to be incredibly challenging. They're meant to ensure that you're able to relate the concepts of the course, in other words, those intended learning outcomes, to a variety of problems.